Hello everyone, how are you? I hope you all are fine and doing well. So I'm Poonam Sharma. Welcome you all another session of Science with Stuti Academy. So in previous classes, I have already explained chapter number 1 of chemistry, matter in our surroundings. And if you want to revise that chapter, kindly go through previous videos which I have already uploaded. And in those videos, I elaborated many practice questions which are extremely important according to exam point of view. So now in today's class, I'll start with chapter number 2, is matter around us pure? Now students, in previous chapter, we have studied about matter, its classification, how we classify matter physically on the basis of its physical properties. So we classified matter on the basis of its physical properties as solids, liquids, and gases. And how do they exist in nature? What kind of arrangement particles they have? Apart from that, we have already studied about the effect of temperature and pressure on these states of matter. So now in this chapter, we'll study about this matter and how we classify matter on the basis of its chemical composition. So if you look around yourself, there are so many things which you are consuming on daily basis. For instance, you drink milk, you eat food, sugar, flour, everything. You are consuming so many things on daily basis. So sometimes the question comes in our mind whether they are pure or impure one. So how can we classify those substances as a pure substance and impure substance? On what basis or what criteria we have to follow when we are segregating these materials into pure and impure one? And all these things are known as matter. So if we are talking about classification of matter on the basis of its chemical composition, so we classify this matter into two main broad categories, which is impure and pure. Here the question comes, what is pure substance? As the name itself shows pure substance, it means it is exists in nature in its purest form. It is uh, free from impurities. No adulteration is present in these materials. And those substances are known as pure substances. It means if we define a pure substance, then how can we define it? It means that the material which is free of any impurities or there is no adulteration present in it. Okay? So now we classify pure substances into elements and compounds. And the second one is impure substances, or we call them mixtures as well, because they are mixed with some other materials. They do not exist in nature in their pure form. So we'll study about these two different substances in detail in this chapter. First, I'll talk about pure substance. For example, distilled water, copper metal. So they are made up of only one type of material. If we talk about copper, copper metal is made up of copper atoms only. It's an element. It is made up of copper atoms only. So that's why it falls under the category of elements and the pure substance. But if we talk about seawater, seawater is a combination of many impurities. Apart from water, it has salt also. So it doesn't come under the category of pure substance. So that's the difference between pure and the impure substances. So first of all, we'll take pure substance, and there are two types of pure substances, elements and compounds. So first I'll take elements in detail. Elements are those substances which cannot be broken down into simpler substance by any physical or chemical means. any physical or chemical method, if we are applying on it, we cannot segregate it. So those materials or those substances are known as elements. And the example of such kind of elements are copper, oxygen, aluminium, hydrogen, gold, silver. N number of examples are there which fall under the category of elements. And if we talk about compounds, in these compounds, they also come under the category of pure one. But if we are saying that compounds are those substances which have fixed composition of different elements, but they are present in a fixed composition by mass, and they can be separated by any chemical methods or by electrolytic electrochemical reactions. So these compounds also come under the category of pure substances. On one side, we are saying pure substances are those which contains only one type of a material. But here compounds, they are made up of two or more elements. Still they come under the category of pure substance. What's the reason? Because whatever substances are present in compounds, they are present in a fixed composition. Their composition is fixed, and they can be separated by chemical methods. So these two come under the category of pure substances. An example of compounds are water, sugar, salt. They are compounds. Now, second is impure substances, or we call them mixtures as well. And they are of two types, homogeneous and heterogeneous. Homogeneous are those which have uniform composition. Uniform composition means if we mix them together, we cannot identify their boundaries. We cannot detect their boundaries. For example, if you mix sugar and water and stir it properly, you can't detect where is the sugar boundary and where is the water boundary. So it's very difficult for us to detect the boundaries. So that's why they form a homogeneous mixture. Or another example, if you'll take salt and water, stir salt into water. So you cannot judge which one is the salt one and which one is the water one. So that's a homogeneous mixture. And heterogeneous mixture are those which do not have any uniformity. It means their composition is non-uniform. There is no uniformity. We can easily see their boundaries. Try to mix oil and water. You can easily see the layer of oil, and you can easily see where is water. So that layer of oil is easily separate from the water. So these are two mixtures. They come under the category of impure substances. And one is homogeneous and the second one is heterogeneous. So we'll study about these elements, compounds and mixtures in detail in this chapter. I hope till here it's clear to you. So we divide matter on the basis of its chemical composition into main two categories, pure substances and impure substances. And impure substances are also known as mixtures. So pure are of two types, elements and compounds, and impure are of two types, homogeneous and heterogeneous. Now first, I'll discuss a few questions with you. Classify brass and diamond as element and mixture. See, we take an example of brass and diamond. Brass is an alloy, which is a combination of two or more elements together. So if we talk about brass, it's a homogeneous mixture. Because when we combine these two metals together, they combine so nicely. They mingle up together so nicely that we cannot differentiate their boundaries. So it's a homogeneous mixture. And if we talk about diamond, diamond is an allotrope of carbon. So this diamond is an element because it is made up of only carbon atoms. Although it is an allotrope, here it's an allotrope of carbon. Now, if we talk about next is Elements. So we'll study about elements in detail. Now, as I told you, elements are those substances which cannot be break down into two or more simpler forms. And they are made up of only one type of substance. As I have already given examples, so many examples to you, like oxygen, hydrogen, copper, aluminium. So these are all examples of elements. And these elements are further of three different types: metals, non-metals, and metalloids. So first we'll study about these type of elements in detail. In your junior classes, you have already studied about these metals and non-metals, their physical and chemical properties in your 8th standard also. So here we'll study about these metals, non-metals and metalloids in detail. First, metals. Now, if we talk about properties of metals, example of metals are copper, gold, silver, aluminium, zinc. They all are examples of metals. And what properties do they have? If we talk about metals, they are highly malleable. Malleable means we can easily convert metals into sheets. We use aluminium foil in our kitchen. So have you seen that aluminium foil? It's quite very thin. It's a sheet form. It comes in a roll form. And when you open that roll, it spreads in a sheet one. So it's just touch that sheet. It's very, very thin. So metals have this tendency that we can easily convert them into thin sheets form. And these metals are highly ductile also. We can convert them into thin wires. Electrical wires which we are using in our house, they are made up of copper and aluminium. Although they have plastic covering over them, and that plastic covering is of different colors. It might be yellow, red, blue, green, black. So, and why we use this black covering over these wires? Because plastic is an insulator. It does not allow electricity to pass through them. And these copper, aluminium wires, they are good conductor of electricity. So to protect ourselves from any electric shock, we cover those wires with plastic covering, and color varies. Metals are highly malleable. It means we can easily convert them into thin sheets. We can not only aluminium can be converted into sheets, we can easily convert gold, silver, aluminium, copper. We can easily convert all these metals into thin sheet form. And they are ductile, as I told you. We can convert them into wires form also. And they are good conductors of heat. They allow the heat to pass through them. They are very good conductor. Why metals are good conductors of heat? See, these metals, they have ions, they have charges in them. They can lose electrons. So they have free electrons in them. That's the reason they considered to be good conductors of electricity, heat and electricity also. So that's the reason why we use metals in making electrical wires. So that's the reason we are using it. Apart from these, metals are lustrous. It means they have shine. Gold, silver, aluminium, copper. If you see all these metals, they are shiny in appearance. So that shiny appearance property is known as lustrous. So they have this property as well. Apart from this, they are good conductors, they are malleable, they are ductile, they are lustrous, and they are sonorous also. Sonorous means when any metal hit to any object, it produces sound. When we throw any metal on the floor, some sound is produced. It means metals have this tendency to produce sound. So that property is known as sonorous property. Apart from this, metals are solid at room temperature, like copper, gold, aluminium, except mercury. Mercury is liquid at room temperature. Okay, and apart from this, metals have high density, except sodium and potassium. Metals are quite hard, except again sodium and potassium. Sodium and potassium are so soft that you can easily cut with the knife. They are exceptions in metals. Then they have high densities also. High densities, if you remember, in chapter number 1, I explained this term density to you. Density is mass upon volume. And metals have high densities, except sodium and potassium. They have very low melting boiling points. They have very low densities. Then these are the properties of metals, and they have high tensile strength. They are quite very strong. So these are the properties of metals. These are physical properties. Metals are malleable, ductile, good conductors of heat. They are lustrous, they are sonorous, they have high density, they have high melting point and boiling point. But few exceptions are there. And we'll study about these metals, their physical and chemical properties in detail in 10th standard. So here I have just discussed physical properties of metals with you. Then next is non-metals. These non-metals are entirely opposite to those of metals. And examples of non-metals are sulfur, oxygen, fluorine, chlorine. So they are examples of non-metals. And if we talk about physical properties of non-metals, they are entirely opposite to those of metals. Let's see how they are different from metals. Here we are saying metals are malleable, but non-metals are non-malleable. We cannot convert them into thin sheets. They don't have this tendency. So metals are non-malleable. Metals are non-ductile. It means we cannot convert metals into thin wires. So we cannot convert them, we cannot draw into wires. So they are non-ductile. And non-metals are bad conductors of heat, except graphite. Except graphite. Apart from graphite, all other non-metals are bad conductors. And graphite is the exception. Why graphite is a good conductor? Due to the arrangement of the layers which are present in graphite. So due to this, they have a slippery arrangement of carbon particles in them. As a result, they are good conductors of heat and electricity. So this is an exception only. Except graphite, all non-metals are bad conductors of heat. It means in metals also there are some exceptions. In non-metals also there are lots of exceptions. Then non-metals are non-lustrous. They don't have any shine, except one non-metal is there which is the brightest among all the metals and non-metals, and that's it. That's a diamond. Yes, diamond is a non-metal. It is an allotrope of carbon. Carbon exists in nature in two forms, diamond and graphite. They are allotropes. And what are allotropes? Allotropes are those substances in which when any element exists in nature in two or more forms. So that's known as allotrope. So carbon exists in nature in two forms, diamond and graphite. And diamond is very, very shiny in nature. It's extremely shiny. So except diamond, all other non-metals are non-lustrous. Then non-metals are known sonorous. It means they do not produce any sound. So when you hit non-metals on the ground, they do not produce any kind of sound like the metals. So non-metals are non-sonorous. And non-metals have low density. They do not have high density except diamond again. So diamond is the exception, which have very high density. Otherwise, all the non-metals are having very low density. And non-metals have low melting and boiling point again, except diamond. So these are the properties of non-metals. One more property is there. Non-metals are bad conductors of heat, as I told you, except graphite. Okay, so these are the physical properties of metals and non-metals. And they both are elements because they both are made up of same type of atoms, same type of material. If we take an example of sulfur, sulfur is made up of only sulfur atoms. If we talk about oxygen, oxygen is also made up of only oxygen atoms. And if we talk about copper, copper is made up of only copper atoms. So these metals and non-metals, although their properties are different, but they both fall into the category of elements, which is a pure form of a metal. Now the third one is metalloids. So metalloids are those substances which have common property, which show some properties of metals and some properties of non-metals. And examples of metalloids are silicon, boron, arsenic, and many more examples are there. So these are three different type of elements: metals, non-metals, and metalloids. And question can come in exam how you can differentiate between metals and non-metals. So in this question, you need to write difference between metals and non-metals on the basis of their properties. Like first is metals are malleable and ductile. As I told you, we can convert metals into sheets, and ductile, we can easily convert metals into wire. And non-metals are brittle. They are neither malleable nor ductile. Brittle means we can easily break them. So if we try to convert them into sheet form or wire form, so they can break. So that's the reason we cannot convert them into sheet or the wire form. So that's the first difference between metals and non-metals. Second is metals are good conductors of heat and electricity. As I told you, due to the presence of free electrons in them, metals are good conductors of heat and electricity. And only those substances are good conductor which have free electrons. When electrons can move, then only current is produced. So that's the reason metals are good conductors of heat and electricity. Now the next one is non-metals. They are bad conductors of heat and electricity. It means they cannot allow or they cannot pass the electricity through them or heat through them, except graphite, as I told you. And we use this graphite in pencil cells. I hope you people know what is pencil cell, that drive cell, which we are using in our remote controls. So that is known as drive cell or the pencil cell. As I show you, this is a pencil cell. If you look at this, and if you remove this covering, so you'll observe that black powdery substance is there inside it. So that black powdery substance is a graphite, which is a good conductor, and it's an allotrope of carbon. Now next is metals are lustrous and can be polished. See, if we talk about metals, shiny appearance, they are very shiny. But sometimes these metals, when they come in contact with oxygen, they lose their shine. But we can easily polish them again and they regain their shiny appearance. For example, we use copper utensils, aluminium. So if we are using them continuously, so they lose their shine. And when you go in market, people are there who polish them. They'll, they'll deposit a layer of that metal over it. Again, it regain its shiny appearance. So metals are lustrous and can be polished if they lose their this shiny appearance. If they lose their shine, and, we use gold and this silver in ornaments. And if we keep on using ornaments on a daily basis, these gold and silver, they also lose their shine. So then we'll go to uh, that shopkeeper, go to jeweler, and that jeweler deposit a layer of gold over it, and it can be polished again. So it again regain its shine. But this case doesn't happen in case of non-metals. Non-metals are non-lustrous. They are quite dull, and we cannot polish them. But iodine is a non-metal which is quite shiny. Diamond also is shiny in nature. Graphite also. So these are the exception in case of non-metals. Apart from graphite and diamond and graphite, I'll just write here. Diamond and graphite, they too are allotropes. Diamond and graphite, they are allotrope of carbon. So they are exception in all these properties in case of non-metals. So these non-metals are non-lustrous, but iodine is lustrous, diamond and graphite is also lustrous. Now, metals are solids at room temperature. If you take an example of copper, aluminium, iron, zinc, gold, silver, so they all are solid at room temperature except mercury. Mercury is liquid at room temperature. That's why we use mercury in thermometers. Mercury has low melting and boiling point also. That's the reason we use mercury in thermometer, because it's liquid at room temperature and it has very low melting and boiling point. So exception in metals is mercury. Then we have non-metals. Non-metals may be solid, liquid or gases at room temperature. The next difference between metals and non-metals is metals are strong and tough. Take an example of iron. You cannot break iron with your hands. You cannot break copper with your hands. Although if you are very strong, you can bend it, but you cannot break it. It's very difficult to break metals. It needs lots of force. It needs lots of energy to break metals. So they are quite very strong and tough. They have high tensile strength also. But if we talk about non-metals, they are not that much strong. They are brittle. We can easily break them. Take an example of graphite also. Graphite is present in pencil lead. So you can easily break that lead. You can sharp your pencil and try to break the tip of pencil, which is made of graphite. You can easily break it. So non-metals are quite brittle. But diamond is quite the hardest substance. So it is the exception in case of non-metals. So you need to learn these exceptions also in case of metals and non-metals. So this is how metals are different from non-metals. Then we have compounds. As I told you, in compounds, the elements are present in a fixed ratio. Compounds are made up of two or more elements when they combine together, when they mix together, but they are present in a fixed ratio. So that's why these compounds also fall under the category of pure substances. And if we study about their characteristics, the properties of characteristics differ from those of its constituents. It means when you take two elements together and mix them, and then a new compound is formed, that compound property is entirely different from those of the elements which were involved in its making. For example, if a H2 plus O, H2O, This is hydrogen, this is oxygen, and water. Oxygen is known as the combustion, and water can be used to extinguish fire. So the properties of water is entirely different from those of hydrogen and oxygen. So this is an example of compound. It means the properties of compound different from those of its constituents, which were involved in its making. So here is an example which I've just given you. Another example like CO2. That's carbon dioxide gas. And the property of this carbon dioxide gas is entirely different from those of this carbon and oxygen. Now next characteristics of compound is they have fixed melting and boiling point. Because the elements which are present in them, they have fixed melting and boiling point. So when they mix together, when new compound is formed, that compound also has fixed melting and boiling point. And this compound is a homogeneous mixture. Sorry, homogeneous substance. Not mixture, it's a homogeneous substance. Homogeneous means, look at this example of water. So when hydrogen and oxygen combine together or mix together, they form water. Once these two elements combine together, we cannot detect where is hydrogen, where is oxygen, but we can separate them. We can separate them by chemical process or by passing electricity through them. So we can easily separate them, but once they mix together, so the way they mix, we cannot differentiate their boundaries. So it's a homogeneous mixture. It's a homogeneous substance, not a mixture. It's a homogeneous substance. And these constituents elements which are involved in making of compound, they can be separated by chemical processes or by passing electricity through them. That's known as when we pass electricity, so we can easily segregate those substances which are involved in that compound. So these are the characteristics of compounds, and they are also pure substance. And the reason is because whatever elements are present in them, they are present in fixed ratio. That's why they come under the category of pure substances. Now, what type of question can come in exam? First example is just in front of you. What are compounds? List some of its characteristics. So here you need to write down the definition of compounds, which I have just explained to you, that compounds are pure substances which are made up of two or more elements when they chemically combine in a definite ratio. So students, when you're writing definition, this is very important statement. Compounds are those pure substances which are made up of two or more elements. When we combine them, chemically combine them, they are combined in a definite ratio. So that's why I'm saying that again and again I'm emphasizing on this. So if you not write this, then you'll not get any mark in this question. And list some of its characteristics which I have just discussed with you. Like properties of compound differ from those of its constituents. Like whatever elements are involved in its making, their property and the compound property, they are entirely different from each other. And compounds have fixed melting and boiling point. Compound is a homogeneous mixture and they can be separated by chemical processes. So these are the characteristics of compounds. When the question comes, generally this question comes in 2 marks. So when this question comes in 2 marks, so you need to write first its definition and then its characteristics. Now, or sometime in exam, only definition can come in 1 mark. So in that question, you have to write only definition. Apart from this, Sometimes the question comes when they ask differentiate between elements and compounds. Differentiate. This is also a very important question. Differentiate between elements and compounds. And whenever any difference come in exam, try to write in tabular form. And in this question, you need to write differences between elements and compounds. Like elements, they are made up of same type of atoms. They are made up of same type of substance. In compounds, they are made up of two or more elements when they are mixed in a definite ratio. Elements cannot be separated by any physical method. Compounds can be separated by chemical methods or by passing electricity through them. And the elements, the properties of all the atoms which are present in elements are same. But if we talk about compounds, the properties of compounds is different from its constituents. But it will not happen in case of elements. Because like carbon, so they are made up of carbon atoms only. So all the carbon atoms have same properties. And if we talk about oxygen, all oxygen atoms which are present in oxygen, they have same properties. So that's the difference between elements and compounds. And these elements, so you can write differences like this when the question comes, and generally this question comes in 2 marks. How can you differentiate between elements or compounds? Or sometimes their definition can come in exam. Definition comes in 1 mark only. So in that you need to write only definition, no need to give any explanation if it's not asking question. Okay. Then till here, if you have any doubt, if you have any queries, just write in the chat box. I hope till here the elements and compounds are very much clear to you, how they are different from each other. So I'll just revise whatever I have discussed with you today. I have discussed about matter, how we chemically classified matter into different categories, pure substances and impure substances. Impure substances are known as mixtures. Pure are 2 types, elements and compounds. Impure are of 2 types, homogeneous and heterogeneous. We'll study about these in detail later. Then I have discussed this question with you. Then what type of elements do we have? We have elements like metals, non-metals and metalloids, how they are different from each other, that I've already elaborated to you. Then what are compounds and what are their characteristics? So I hope till here it is clear to everyone. And if you want to ask, you can please write, or you can ask your doubt if you have. And these type of questions generally come in exam. What are compounds? List some of its characteristics. Or what are elements? That can also come. What are elements? What are elements and its characteristics? So these are frequently asked questions in exam. So thank you everyone. Just revise it, whatever I have explained today in the class, go through it so that when I'll take your next class, so this topic is